Okay, this is lesson 4-4. We are still proving triangles congruent, but we're going to start talking about a couple shortcuts. There's actually 4 total shortcuts that we're going to talk about. So, in the last lesson, 4-3, we talked about Cpctc. Remember that? Corresponding parts of congruent triangles are congruent. It's whenever we prove all 6 parts, 3 sides and 3 angles, of one triangle are congruent to all 6 parts, 3 sides and 3 angles, of another triangle, right? And we can say that the 2 triangles are congruent when we know all their parts are congruent. Well, there are some shortcuts to where we don't have to use or prove all 6 parts are congruent. We can just stop at 3, right? We don't have to quite do all the work. Okay, so the first shortcut, there's 4 total. The first one is called side, 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 or SSS, the SSS postulate. If 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. So actually, we don't even have to prove anything about the angles if we know for a fact that all 3 sides are congruent. Okay, so here's an example, and then we'll do a couple on our own. Here's a little proof example. Given that AB is congruent to DB, and they're marked here. AB is congruent to DB. This guy is congruent to this guy. And C is the midpoint of AD. Prove that the 2 triangles are congruent. So first, they list the given. And they actually list it in 2 lines. You don't have to. You could just put it all under line 1. That's fine. But they did it. Okay, after they listed the 2 pieces of the given, next they said that AC is congruent to DC. So they said this guy is congruent to this guy. And how do we know that? If C is the midpoint, how do we know that this guy is congruent to this guy? The midpoint theorem, right? A point in the middle of a line, the midpoint of a line, separates our line into 2 congruent halves, right? So AC is congruent to CD because of the midpoint theorem, and the given tells us that C is the midpoint. 4, BC is congruent to itself. 1, 2, 3. BC is used in the left triangle and the right triangle, and it's the same line segment. So it's the same size no matter which one we're using it in. And when you say that something is congruent to itself exactly, that's always reflexive, the reflexive property of congruence. So now I've proven that all 3 sides of the left triangle are congruent to all 3 sides of the right triangle. So I can go ahead and say that the entire triangles are congruent because of SSS. You don't even have to say the word postulate. You can just say SSS. Now, if I asked you, okay, well, does that mean that angle A is congruent to angle D? Yes. Once I say that the triangles are congruent, that means everything about them is congruent. But I don't have to prove that first. All I have to prove is that all 3 sides are congruent. And then that tells me that the angles must be as well. Okay, so let's do a couple proofs here on our own. I'm going to cut this whole lesson into 2 videos so it won't be too long. All right, write a 2-column proof, it tells us here. So for number 1, we've got these 2 triangles, and it says given this, this, and this, prove our triangles are congruent, right? So I'm going to write my 2-column proof. I don't know how long it's going to be, so I'll just kind of make it whatever. Statements. Don't forget to label your proofs. Reasons. Number 1, AB is congruent to XY. Number 1 is given. I'm just going to put all mine in number 1. You could separate it into 3 lines if you want. I don't want to. AC is congruent to XZ. And BC is congruent to YZ. So that's all in number 1, and they already marked them. Do I have enough right now to say that my 2 triangles are congruent? Yes, I do. I don't even have to do anything, right? Now I can go ahead and just say that triangle ABC is congruent to triangle XYZ. And what's my reasoning? Because of side, side, side. Because I proved all 3 sides of one triangle are congruent to all 3 of another. So now I know that everything about the 2 triangles are congruent. Literally that easy. Let's do this one. Remember, all we're focused on is side, side, side. So we're only worried about the 3 sides of our triangle. So I'm also going to write another 2-column proof. Statements. Reasons. Okay, it starts off telling me in number 1 that RS is congruent to UT. And RT is congruent to US. And that's given to us. Okay, and it's already marked for us. RT is congruent to US, and RS is congruent to UT. Okay, and I'm worried about proving all 3 sides of one triangle are congruent to all 3 sides of another. The only side missing from both now is TS, and it's shared. It's used in both triangles. So for step 2, I'm going to say TS is congruent to itself. It's congruent when we use it in the left triangle. It's the same size as when we use it in the right triangle. And whenever I say that something's congruent to itself, that's the reflexive property of congruence. And you do not have to write property of congruence. You can just write reflexive. Okay, so once I've marked all 3 sides of one triangle congruent to all 3 of another, now I can say that the triangles themselves are congruent. So triangle RST is congruent to triangle UTS. I'm just repeating the proof. And what's my reasoning? Because of side, side, side. Because I proved all 3 sides were congruent. 1, 2, 3 sides. Okay, hopefully that makes sense. Video 2 to follow.